Hello students. The next code today we are going to see is 3:8 decoder. We are going to write the RTL and the test bench. Before entering into the session, please subscribe my channel VLSI with Dr. Leena. So what is 3:8 decoder? 3:8 decoder is a combinational circuit that takes 3 input bits and it produces 8 output lines. Only one output is high at a time and all the other output remains low, and that is why it is called one hot output circuit. And here it is 2 power 3 is equal to 8, so 3 input bits can represent 8 combinations. Let us see one table and one small examples and then proceed to the RTL code. Yeah, you see here inputs. If input is 0, 0, 0, the output will be 0, 0, 0, 0, 0, 0, 0, 1. And it selects the output 0. And when 0, 0, 1 input, the output will be 0, 0, 0, 0, 0, 0, 1, 0. And it selects the output 1. Let us see how this is working. See, if input bit is equal to 3-bit binary 101, that is 101, then the binary value of it is 5 and the output becomes 0, 0, 1, 0, 0, 0, 0, 0. That means the output line 5 becomes high. Similarly, for all the cases, this is applicable. Yeah, first we are going to start the RTL code for 3:8 decoder. That is, first we are giving the module and the module name and opening the bracket. A 3:8 decoder converts 3 input bits into 8 output lines. Next, we have to give the inputs and outputs. Look at this. We are giving the input, that is, we are giving as in and 3-bit input 0 to 2, and possible values are 0, 0, 0 to 1, 1, 1. That is 8 combinations. And next we are assigning output. That is, here it is 8-bit 1 hot output. We represent it as OUT. It ranges from 0 to 7, totally 8-bit output bus, and it is given as rich because the output is assigned inside an always block. Here only 1 bit becomes high at a time, so called 1 hot output. And after assigning the inputs and outputs, we are going to close the bracket. Look at this, we closed. After closing this, what we are going to do? We are going to do the operation of this 3:8 decoder. Here, look at this, we have given always at, open the bracket star, and we have begin it. This always block describes combinational logic. And this at star means execute whenever any input changes, and it is used for decoder logic implementation. After this, the next step we are going to do is out is equal to 8-bit binary 0. As we all know why we are using this means, initially we are making 8-bit binary 0. This prevents latch creation. And then the next is case in. Why we are giving this? The case, it checks the value of the input IN. Based on the input value, one output line is activated. And next is we are giving the conditions, that is input 3-bit binary 0, 0, 0. When it is 3-bit binary, if the input is 0, 0, 0, then it selects the output 0, 0, 0, 0, 0, 0, 0, 1. And the output out 0 will be high. And next condition is 3-bit binary 0, 0, 1. When this is given, it selects 0, 0, 0, 0, 0, 0, 1, 0. That is out 1. will be high. And similarly for the next condition, out 2 will be high. Similarly, it will be continuing for every conditions. And then we give finally default. That is, if input is invalid or undefined, all the output remains 0. This provides safety for synthesis and simulation. After doing this, we are ending the case and then we are ending it. Finally, we are ending the module. So this is the RTL code of 3:8 decoder. Now let's see how to write the test bench of this decoder. Yeah, now we are going to write the test bench 3:8 decoder test bench. That is, we are going to give the module, and for the module we are going to give the name. After giving the module names, we have to assign the inputs and outputs using reg and wires. So first we are giving the input using reg, and then we are giving the output using wire. After giving the input and output, the next step we have to do is we have to instantiate the module inside this test bench. So we are instantiating. For instantiating, what we do? First thing is we give the name which we have given for the module in the RTL code. The name we will be giving it here, and UUT, that is nothing but unit under test, and we are opening the bracket, and then the next step we are doing is we are connecting the test bench input to the module input and the test bench output to the module output. After that, we are closing the instantiation. In all the course, the first step we do is we give the inputs and outputs using reg and wire, and then we instantiate. After instantiating, we will be giving the test cases. For that, we initially begin, and then we are applying all the input combination with 10 nanosecond delay. Yeah, in the first input combination, that is in is equal to 3-bit binary when it is 0, 0, 0. When the input is 0, 0, 0, decoder activates the output line 0, that is out 0, and wait for 10 time unit and execute the next combination. Next, when the input is equal to 3-bit binary 0, 0, 1, when it is 0, 0, 1, then it activates the output out 1, that is 0, 0, 0, 0, 0, 0, 1, 0, and it waits for 10 time units and checks the next input condition. Similarly, it will be checking the all input condition. Finally, after all input conditions are overing, it finishes the simulation, and then it ends the process and it ends the module. So this is the code for the test bench of decoder. Now let's see the output waveform. Now this is the output waveform of the decoder. Look at this. When input is 0, 0, 0, the output will be 0, 0, 0, 0, 0, 0, 0, 1. That is, output 0 will be active. Then when input is 0, 0, 1, the output 1 will be active. Similarly, when it is 1, 1, 1, the output 7 will be active. Let us see it in the waveform window. Look at this. These are all input conditions and these are all outputs. 3-bit input, that is when input is 0, 0, 0. See, when input is 0, 0, 0, output 0 is active. Look at in the output. Output 0 is active. When input is 0, 0, 1, the output 1 is active. When the input is 0, 1, 0, the output 2 is active. Similarly, it goes for all the conditions. That is, when input is 1, 0, 1, the output 5 is active. And when the input is 1, 1, 1, the output 7 is active. So this is the waveform of decoder. And students, today we have completed the decoder, and next we are going to see BCD to 7 segment, ALU, addition, subtraction, all the codings, And if you want to learn more codings, please subscribe my channel VLSI with Dr. Leena. Thank you.